In the got it, we just have two options, A or B. It says the office manager of a small office ordered 140 packs of printer paper, kind of like Miss Jacobs would. Based on an average daily use, she knows that the paper will last about 80 days. What graph represents this situation? Well, as the days increase, as the days go up, what happens to the paper amount? She's probably going to use it, right? So I want you to look at this. Can you see how this point right here, it starts at 140? That makes sense because on day number 1 or day number 0, she has 140 packs of paper. In 80 days, see that 80? In 80 days, it's going to run out. Option A is our answer because the papers are running out. This one would be if it was growing, but they're not growing, it's decreasing. Moving on, we're going to talk about parallel and perpendicular lines. Parallel lines look like this. The slopes are the same. Let's write that down. Slopes are the same. The y-intercepts are different. For perpendicular lines, the slopes are opposite reciprocals. So we talked about this a little bit at the beginning of the lesson. There's a couple of other things down here worth mentioning, and it's this. If you have a slope of 0, you should remember that the line is horizontal. You should know that the parallel slope would also be 0. So the line would again look like this. But you should remember from Algebra 1 that the perpendicular slope would be undefined. And that means it would be a straight up and down line. Now you should remember a couple of things about zero slopes. Zero slopes on the y-axis, like they occur at the y-axis because they go through the y-axis. They are always y equals a number. There will never be an x. Okay, that's for horizontal lines, there will never be an x. For perpendicular lines, it will always be for vertical lines, it will always be x equals a number. There will never be a y. Moving on, we're going to talk about in problem 6, parallel and perpendicular lines. First, we're going to talk about in A, the equation of a parallel line. Given y equals 6x minus 2, please label that as the old line. And you wanted this to go through a new point. What would the new equation be? Now, if you're a visual learner like I am, I'm going to show you on your calculator what's going on. That is the graph of 6x minus 2. That is the old line. 1, -3 is somewhere down here. We need to come up with an equation of a line that goes something like this. It's parallel to our old line, and it runs through -1, 3. Or excuse me, 1, -3. So here are your steps. Follow them carefully. Step number 1 is the old slope. The old slope is y equals mx plus b is 6. Step number 2, we need the parallel slope. Well, the parallel slopes are the same, so the parallel slope is 6. You never need to use that again. Step number 3 is to identify your new information. Okay, so I labeled my new information. Step 4 is to make your new equation. I am going to make it using y minus y1 equals m times x minus x1. So I will do y minus negative 3, so plus 3, equals my slope, 6, times x minus x1, which was 1. I will distribute my 6 in and get y plus 3 equals 6x minus 6, and I will take away 3. Y equals 6x minus 9. So this is the new parallel line. If you want to see it in your calculator, it would be 6x minus 9. Take a look how it's almost exactly where I said it was going to be. It goes through 1, negative 3, and it is parallel. We're going to keep going. We've got to talk about perpendicular now. What is the equation in slope-intercept form of the line that is perpendicular to negative 4x plus 2/3? Okay. This is the old line. This is the old line. Now I need to make a note to you, alright? This should always be y equals. If it's not y equals, you need to put it into y equals. Alright, now we have a new point, 8, 5. If you're a visual learner like I am, I want to show you how we're going to do this. Here's negative 4x plus 2/3. Let's take a look at the graph. There's the graph. Now we want a new graph that is going to be, it says perpendicular, and it's going to go through 8, 5. So here's over 8 up 5. So we're going to have a line that makes a right angle. So something like that is what our new line is going to be. It's going to go through 8, 5. It's going to look a lot better than my line. It's going to go through 8, 5, and it's going to be perpendicular. All right, here we go. Step 1. Old slope is negative 4. And you get that from y equals mx plus b. Step 2. Your perpendicular slope is your new slope. Remember that perpendicular is the opposite reciprocal, okay? So first of all, it's a positive 1 over 4. I changed the negative to a positive, and I flipped my fraction. You never need number 1 again. Step 3, you'll label your new information, 8, 5. In step 4, you use whatever you want. I like y minus y1 equals m times x minus x1. And I plug in accordingly. So that's y minus 5 equals 1 over 4 times x minus 8. Okay, I'm going to put this on y equals mx plus b, so I'm going to distribute. So I'll get y minus 5 equals 1 over 4x minus 1/4 times 8 is minus 2. I'm going to add my 5, and I get y equals 1 over 4x plus 3. Now if you want to see how well we did, go back to your calculator. You plug in 1 over 4x plus 3, graph it, along with your old line, negative 4x plus 2/3, and you will see you get perpendicular lines that run through 8, 5. Alright guys, we only have one more. We can do this. I know it's getting long. We're almost done. We're going to try the parallel one more time, and we're going to try perpendicular one more time. Alright, what is parallel to 4x plus 2y equals 7? And it goes through 4, negative 2. So what we need to do first is this needs to be in y equals. So we're going to take the 4x over, so we're going to get negative 4x plus 7, and we need to divide by 2. You need to make it y equals. Absolutely needs to be in y equals. So y equals negative 2x plus 3.5. Now you see that? That's why we put it in y equals, because that's your old slope. Alright, step 1. Old slope is negative 2. Step 2. The parallel slope, because that's what they wanted, is parallel. The parallel slope is also negative 2. You don't need step 1 anymore. Step 3, the new information is your new point of 4, -2. And step 4, I like to use y minus y1 equals m times x minus x1. You do not have to. You may use y equals mx plus b and solve for b. Either way, you're going to get the same answer at the end. In mine, I get y minus -2, in other words, y plus 2, equals m, which is -2, times x minus the x of 4. Now I will distribute in. That's y plus 2 equals -2x plus 8. And then you need to minus 2. That's y equals -2x plus 6, because 8 minus 2 is 6. There it is. One more, guys, and that's a perpendicular. What is perpendicular to y equals 2 over 3x minus 1? And it goes through the point 0, 6. That is your old line. And notice it's already in y equals, so we're happy with it. Alright, so step 1. The old slope is 2/3. Step 2. The perpendicular slope is opposite reciprocal. So it's -3 over 2. Now you no longer need step 1. Step 3. My new information is my point 0, 6. Step 4. I like to use y minus y1 equals m times x minus x1 and plug in. You may use y equals mx plus b and solve for b. So that's y minus 6 equals my m of -3 over 2 times x minus 0. Distributing it in, I get y minus 6 equals -3 over 2x. I'm not even going to bother with the 0. And last, you add 6 to get y equals -3 over 2x plus 6. So just take a look at the difference. The last thing, and I promise it's the last thing, is I want to make sure you understand one little quirk about perpendicular slopes. Perpendicular slopes. Here it is. You ready? Always multiply to -1. And that can be, if you guys are questioning how to do that, you can see if you did it right. For example, if you have 2 over 3, what is perpendicular to that? -3 over 2, right? If you multiply those together, you will get -1. Another example, to show you one more time, if you have a slope of -6 over 5, and you multiply by the perpendicular slope of +5 over 6, you will get -1. And that is how you can always check to see if you did perpendicular slopes correct.